Let us take an example of a matrix 3 by 3 order and decompose it to the lower triangular and upper triangular matrix, product of lower triangular and upper triangular matrix. Just reduce this 3 by 3 to the product of two matrices. One is lower triangular, so we choose 1 0 0, A1 1 0, then A2 A3 1. This is the lower triangular matrix. And in case of the upper rectangular matrix, we get the values as B1 B2 B3, 0 B4 B5 and 0 0 B6. This is the form of upper triangular matrix. So if we multiply this becomes B1, this into, actually the first column we multiply with first row and we get the 1 1 element. Then first column into second row gives A1 B1, and then first column into third row gives A2 B1. Then you multiply with second column the first row and it gives B2. Then second column into second row gives A1 B2 plus B4, and then we have second column into third row that gives A2 B2 plus A3 B4. Then you multiply with third column, the first row it gives B3, then third column with second row it gives A1 B3 plus B5, and whenever you multiply the third column with third row it gives three elements, A2 B3 plus A3 B5 plus B6. So this is the matrix which should be equated with this, and if we equate the terms one by one, what we get is that this B1 becomes 1, B1 is 1, B2 is 2 and B3 is 3. These are straightforward. Since this matrix is written as the product of these two, we must have B1 1, B2 2 and B3 3, and then A1 B1 is again 2. A1 B1 is again, sorry, the product A1 B1 is a product, it is 2, and since B1 is 1, so A1 is actually 2. Okay, then we have A1 B2 plus B4. This is the term when we multiply second column with second row, so A1 B2 plus B4, this is 1, and since A1 B2 plus B4 is 1, this is 1, and we have already A1 equal to 2 and B2 equal to 2, so we have B4 as 1 minus 2 to the 4, so B4 is minus 3, 1 minus 4 is minus 3, so B4 is actually minus 3. Then let us look at A1 B3 plus B5. A1 and B3 plus B5 is nothing but this element, which is 3, isn't it so? A1 B3 plus B5 we get when we multiply third column with second row, so it is the 2 3 element, A1 B3 plus B5, this is 0 and this is equal to 3. So what will be B5? Since B3 is 3 and A1 is 2, so 3 to the 6 and B5 becomes minus 3. B5 becomes minus 3. Then we have A2 B1. A2 B1 is again 3 and B1 is 1. So A2 is 3. clearly. Then we have A2B2 plus A3B4. A2B2 plus A3B4, and that is 2. A2B2 plus A3B4, that is 2. Now we have B2 as 2, A2 as 3. So A2B2 is nothing but 3 2s are 6. And B4 is minus 3. So this is minus 3A3. This is minus 3A3, and this is 2. So A3 becomes 2 minus 6 is minus 4. A3 becomes 4 by 3. A3 becomes 4 by 3. A3 becomes 4 by 3. Now we have the last element, which is A2 B3 plus A3 B5 plus B6, which is nothing but 1. This is the 3 element. So when we are multiplying with the third column, the third row, we get A2 B3 plus A3 B5 plus B6. This is the only term where we get 3 entries. In all other terms, we have either 1 entry or 2 entries. So this term gives us the value 1. And now if we put back all these values of A2, B3, A3 and B5, we get the value of B6. What is the value of B6? B6 is 1 minus, this 1 minus A2, B3. So what is A2, B3? A2 is 3 and B3 is 3. So 3 3s are 9. And A3, B5. B5 is minus 3 and A3 is 4 by 3. So A3, B5 is 4 by 3 minus 3. Isn't it so? And this should be transposed. So this becomes plus 4. Just look at this. A3 into B5. Minus 3 into 4 by 3. So it is minus 4 here. So when you transpose, it becomes plus 4. And this becomes 415. So minus 4. B6 becomes minus 4. Now I will just replace these values here to get that this 1 2 3, 2 1 3 and 3 2 1 may be written as 1 0 0. Then we have A1. What is A1? Nothing but 2. Okay. What is A2? Nothing but 3. What is A3? A3 is nothing but 4 by 3. It is nothing but 4 by 3. Sorry. It is nothing but 4 by 3. Then what is B1? B1 is again 1. What is B2? It is 2. What is B3? It is 3. What is B4? B4 is minus 3. What is B5? B5 is minus 3. And what is B6? B6 is minus 4. So we can write this matrix as this into this. Let us check whether it matches. When you multiply with 1 0 0 this, it is 1. With this, it is 2. And with this, it is 3. Then we multiply this with this. This with this. Second column, first row. Sorry. These are the two matrices. I am showing wrongly that this column into this row gives this one, this column into this row gives this one, and this column into third row gives this one. Then this second column into first row gives 2 into 1, 0, 0 gives 2. Second column into second row, 2 2s are 4 minus 3, 0 0 0 gives this element, a 2 2 element. Second column, second row. This is a 3 2 element. So we must multiply second column with third row. So 2 3s are 6 minus 4 and it is 2. So this column matches. Then we move on to the third column. So third column into first row gives 3 into 1, these 2s are 0, so gives 3. Then third column into second row, third column into second row. This gives 3 2s are 6 minus 3, 3, it matches. Then third column into third row. So 3 3s are 9, 3 3s are 9. And then we have minus 4. When we multiply this with this, it becomes minus 4. And then we have also minus 4. So 9 minus 8 gives us 1. So it perfectly matches. So whenever we have been able to reduce this matrix into this type of lower triangular and upper triangular form, we can easily solve this linear equation xyz in this way. This into this okay. We have just written this A in this LU form, and this is the variable matrix AX equal to LUX. Now we may easily express this part U into X part as a column matrix, and it will become x plus 2y plus 3z. When you multiply this with this, then we have minus 3y, 0 into x is 0, minus 3y minus 3z. So we take the minus 3 common and write it like this, and xyz into this gives us minus 4z. Let us represent this as x prime, y prime, z prime. So you can easily see that Ax is equal to this L, which is 1 0 0, 2 1 0 and 3 4 by 3 1 into x prime, y prime, z prime. Whenever I am taking this u into x as this, u into x as this, so obviously this multiplied by this gives us Ax, isn't it so? Ax is the original equation. We decomposed A into two parts, L and U. One is lower triangular and another is upper triangular, and then we represent this u into x as a new x prime. This is as Lx prime. So Lx prime, this is Lx prime, L into x prime is Ax. This is actually L and this is x prime. So Lx prime becomes Ax. I think you can follow. Actually, we should write here x prime, y prime, z prime, and we should actually this into this is this. So this is the new x prime, y prime, z. And now we write L here 1 0 0, 2 1 0, and then we have 3 4 by 3, 1. So what is x prime, y prime, z prime? They are this. So L will be multiplied with this, with that. So what we do is that we represent this as x prime, this as y prime, and this as z prime. So we have this as x. Now let us take the equation as ax equal to the original equation as ax equal to b. So if the b is known, let us take that this b vector to be minus 1 and 0 and 1. So our original equation is nothing but x equal to b, where b is this. So we have x prime equal to minus 1 directly from here, and then we have 2x prime plus y prime equal to 0, and we have 3x prime plus 4 by 3 y prime plus z prime equal to 1. And you know the value of x prime from here, from this relation. What is x prime? X prime is x plus 2y plus 3z. It is nothing but x plus 2y plus 3z. And we will have to substitute the value of 2x prime plus y prime from here. What is y prime? Y prime is nothing but minus 3 into y plus z. And x prime is like this. And we may write it as y prime equal to minus 2x prime. So if we put the relation like this, y prime equal to minus 2x prime, and then substitute the values of y prime and x prime here, we get, since y prime is nothing but minus 3 into y plus z, and x prime is like this, so if we multiply with this minus 2, so this becomes minus 2 minus 4y minus 6z. And we have the relation from here that 2x plus y plus 3z is equal to 0. And then we will have to substitute this value, which is 3x prime plus 4 by 3y prime plus z prime equal to 1, where z prime is nothing but minus 4z. And we can easily replace the values term by term, which gives 3x prime means 3 into this, so it is 3x plus 6y plus 9z plus 4 by 3y prime. Y prime is nothing but minus 3 into y plus z, so this becomes minus 4 into y plus z. And what is z prime? Z prime is minus 4z, and that is 1. And if we add them up, this becomes 3x plus 6y minus 4y is 2y, and 9z minus 8z is plus z, that is 1. So we have this relation along with this relation and this relation. We can solve them to get the values of x, y and z easily. We have y equal to minus 2x minus 3z here. So we substitute the values here. So it becomes 3x minus 4x minus 6z. This is the value of 2y. 2 into this, so minus 4x minus 6z plus z equal to 1. So it becomes minus x minus 5z, or x plus 5z equal to minus 1. And we replace this relation, y equal to minus 2x minus 3z here. So this becomes x plus 2y. Plus 2y means minus 4x minus 6z plus 3z is equal to minus 1. So this becomes minus 3x minus 3z equal to minus 1. That is x plus z equal to 1/3. And you can easily solve these two to find the value of x and z, since x plus 5z is minus 1 and x plus z is 1/3. So we subtract them to get 4z equal to, this minus this means minus 4/3, and z is equal to minus 1/3. And when z is minus 1/3, from here we get x equal to 2/3. So this is the relation, and we can put this value of x and z to find what is y, since we have a relation between x, y and z to get that y equal to minus 3x minus 3z. Okay, so that is the way how we can solve a matrix equation by decomposing the original matrix to a lower triangular and upper triangular matrix.